Hi, welcome to J Talks. I'm Josna Cardoza, and today I'll be talking about the tokenization in large language models. Machines usually do not understand our languages, or text for that matter. Tokenization is the process by which machines read text and understand the language. Large language models don't see words the way we do. Instead, they break text into small chunks called tokens. Tokens are then converted into numbers. We call them token IDs. These token IDs are understood by the model. Today, we will explore how this works step by step. Let's understand first what is a token. A token is a piece of text. It could be a word, subword, or even a single character. Each token is mapped to a number using a vocabulary, which is called token ID. This token ID gets fed into the model. When the model predicts the output text, it outputs the token IDs, which are then mapped back into the words. The model's understanding depends on the size and the content of its vocabulary. It's possible that vocabulary doesn't contain all the words. So how does the model handles unknown words? For example, let's say we have input words, something like some other wordation without any space. Like some other word maybe separately makes sense, but if you give it without any spaces as a single word, that big word doesn't exist. So older models struggled with unknown words and they used a special token like UNK token to replace any word that is not in the vocabulary. But the issue was, if there were multiple unknown words, they all got replaced with the same UNK token, making it impossible to distinguish between them. LLMs solve this by breaking the word into smaller tokens. The model checks for the possible combination of the words within the unknown word in the vocabulary. So in our example, we chose some other wordation. It is likely that the word some, other, and word are found in the vocabulary. So it separates those words and keeps the Asian from the word Asian as separate word. In fact, it could further break it down as at, I, and on. But let's say we have some random characters, for the instance, that cannot be broken down into meaningful words. Then this is further taken care by the byte pair encoding algorithm. These days, all the LLMs use byte pair encoding. This solves the problem where we want a vocabulary that isn't too big but still covers rare words. When the model encounters random or unknown characters, it breaks down the word further into individual characters. Then it tries to find the most common pair and merges them. It repeats the process until you build frequent subwords. This approach is efficient, compact, and capable of handling rare and completely new words by breaking them into smaller, understandable parts. Tokenization determines context length, that is, how much text the model can see. It impacts efficiency. It also defines how well the model handles different languages. And this is why it matters the most, especially in LLMs. I have added a GitHub link in the description with a simple workflow of the tokenization process. Please check it out for more clarity. Tokenization is the bridge between human language and machine language. Tokens let LLMs turn our messy word into clean numbers. And back again. Byte-pair encoding techniques help the models to handle any word, even ones that don't exist yet. I hope you found today's talk useful. Please like, share, and subscribe. I'll see you soon in the next talk.